Hello, today we are going to be solving equations with variables on both sides. And this is topic 11-12, learning target 5. So the first thing we want to do is we want to simplify if we can. If there's anything like terms that we need to combine or distribute a property we need to take care of one way or the other, go ahead and take care of that. Then we're going to get all the variables on the same side. So you'll notice down here I have some x's on this side of the equal sign, and I have x's on that side. We want to get all the x's in this case, or variables, on the same side. And then solve your equation from there. So once you get those moved, it'll look very similar to what we've been doing. One little trick that I have is I hate it when the coefficient becomes negative. So I try to keep it positive. So when I go to move, if this is a negative 3x and that's a positive 2x, I know when I move this, I'm going to add 3x, because negative 3x plus 3x, that will get rid of it there. And then when I do that, it gives me a positive coefficient out here in front of my x. And over here, I just have the 1 left. Now I'm going to solve it like I've been solving all of my others. And I get x is equal to negative 1. I'm going to go back in, and I should be able to go wherever that x is and plug in the negative 1. That was where the x was in our original equation, and that's where I've put in what I think x is equal to. And my answer checks out. Did this problem earlier with a student, and we did 1 minus 6, and we got positive 5, and that gave us a positive 1 here, and then we didn't get 4 equals 4. We got something else here, so we knew right away we'd made a mistake, and we were able to go back over and see, oh yeah, this should have been a negative 1, not a positive 1 as my answer. That's why those checks are important. One thing, I'm going to drop it down. I'm not going to subtract 6, because when I do that, 4 minus 6 is going to give me a negative 2. So that's what I'm talking about, that negative coefficient. So I'm going to subtract 4x. So you notice we're moving coefficients with variables the exact same way that we move these constant terms. We just make sure that we take the coefficient and the variable with us. And I get 2x minus 1. Equal to 3, and I add 1 to both sides. We get x equals 2. When I go back up here and I plug those in, I find that my answer is correct. Once again, it's negative. I am going to go ahead and move that. Oh, but do you see what I forgot to do there? So back myself up here. And it's okay to do that. I think a lot of times we get just like I was doing, kind of going quickly, wanting to work through stuff. So negative 7a minus a, so negative 8a is equal to 6a plus 14. So I'm like, oh, I really want to move that negative over there and get rid of it. It's just not going to happen this time. So I'm going to go ahead and subtract 6a, because if I move that, all I have left over here is a 0. And right now we don't want to get our equations equal to 0. I know it ends up working out. I just have to make sure that I divide by negative. I get a equals negative 1. Let's see if that works out for us. Now you'll notice when I plug this back in, you're like, holy cow, that's a lot of negatives. I had a negative 7 here, and my a is negative 1. So there's my negative 1 plugged back in. And then I'm subtracting, but I'm not just subtracting 1, I'm subtracting a negative 1. So this is going to give me a positive 7. These two are going to give me a plus 1 here. Six times negative 1 is negative 6, so I get 8 equals 8, and I find out that I'm still okay there. On this one, I'm going to combine like terms. B plus B is 2B. I'm going to subtract 2B from both sides. Divide by 2 and find that B is 9. Wow, my brain is not functioning right now. There is a... Thank goodness for erasable pens. So 2 times 9 plus 18 equals 4 times 9. I found that, well, at least I got the right answer, even if I kept making little mistakes, and along the way there I was able to catch them. Down here we just have some decimals and some fractions, and you are more welcome to use your calculator if you would like to. I have that negative. I'm going to bring it over. So I'm going to have 5 halves minus 5. And you're like, oh, this doesn't look right, but this is positive 5 halves. Sorry, I was waiting there for it to focus. So this is 2.5, if you want to think of it that way, minus 5 equals negative 2.5. 2.5 minus 5 does indeed give me negative 2 1/2, so it works out. Over on this side, this last one here, add d to both sides. Sorry, can you see my negative there? So I'm getting d is equal to negative 8.9. If I plug that back in, remember that? If that's there, it's wanting the opposite of what it was. So that's going to make it positive 8.9, which is going to make it negative 8.1 on this side. And I find I have the right answer there. Little word problem down here to finish it up. Suppose the temperature in your town is 21 degrees Fahrenheit, and it's rising 1.5 degrees every hour. Your friend lives far away, and the temperature in his town is 28 degrees, and it's falling 2 degrees every hour. How many hours will the temperature, and how many hours will the temperature be equal? So we want to know in how many hours. So I'm going to use H for number of hours. The temperature in your own town is 21 degrees, and it's rising, so I'm going to add 1.5 degrees every hour. And the temperature in your friend's town is 28 degrees, but it's falling 2 degrees every hour. And what I want to do is I want to set those equal to each other because I want to find out, as this one's going up and this one's coming down, when do they cross paths? And I'm finding that it should be in 2 hours that they will cross paths. And so I'm like, In 2 hours, it'll rise 3 degrees for a total of 24 degrees. And over here in 2 hours, it will fall 4 degrees, which is also 24 degrees. And that is when they will equal each other. Once again, make sure you pause and check, and make sure if you have any questions, you ask.